Everyone to our April 2025 Airflow monthly town hall. We hold these on the first Friday of every month to get the community up to speed on what's been going on in Airflow. We have a number of very interesting presentations for you today, 2 top PRs of the month, 2 incredible presentations by Savine and Raul about their Airflow use case at their companies. And as always, your community spotlight, excuse me, with me. And we'll get you out of here at the top of the hour. So one thing to note, pardon, no decisions are made on these calls. If this is your first town hall, please take note of that. If anything's discussed here, we bring it over to the dev list for a formal discussion. Everyone's obviously welcome to attend, and we record every single town hall and post it to the Airflow YouTube channel. I also share that recording in the town hall channel in Airflow Slack. And yet I know someone will ask me, where's the recording? So again, always on Airflow YouTube, and I posted the Town Hall Slack in Airflow Slack. All right, so without further ado, I want to jump into our first presentation. Savin Goyal is going to be discussing building scalable ML infrastructure at outer bounds. So Savin, I will pass it off to you.
Sure. And can I share my screen? Thank you. Hello all. Thanks for having me here. I'm one of the co-founders here at Outer Bounds, as well as maintainer of an open source project called Metaflow, which we started back at Netflix. And because Metaflow has the suffix flow in it and Airflow also has the suffix flow in it, there are many times sort of like confusion if, let's say, both of these two projects are competing against one another and sort of like, trying to go after, let's say, a similar-ish market. In this conversation, I'm going to basically sort of like walk you through what is the philosophy behind Metaflow and how Metaflow and Airflow actually interoperate and are not sort of like meant to replace one another. So just as context, we started building Metaflow back at Netflix way back in like 2018. And then it was open sourced under the Netflix open source umbrella in 2021. And since then, many companies have been using Metaflow to power sort of like, their AI and ML offerings. So if you get your recommendations from, let's say, Amazon Prime Video or Netflix, all of that sort of like, comes through comes through Metaflow. If you send your DNA sample to many of these gene testing companies like 23andMe, all of that processing and analysis is powered through our technology, as well as, when you're, let's say, ordering food through Delivery Hero, DoorDash, it's sort of like our tech working behind the scenes. And basically now with sort of like AI coming in, we are seeing sort of like this very rapid bucketization of different strategies that different companies are following. Of course, if you sort of like step back a couple of years ago when ChatGPT was sort of like a very new thing, at that time, most companies were looking at engaging with embedding AI models or any kind of intelligence into their products by actually just very simply interacting or integrating with those API endpoints and doing some sort of like, lightweight prompt engineering there. And that sort of like is a great first start because it sort of like, gets you to some product. It gets you to understand the technology, the promises of that technology very rapidly. But then it also sort of like then brings upon the question that what is that competitive advantage that you are able to build so that your product is differentiated and you can stand out from competition. And that's where sort of like, if you look at the roots of data engineering, ML engineering, they're all sort of like rooted towards making organizations a lot more efficient, a lot more effective, so that they sort of like, stand a great chance at sort of like competing and winning the market. So most companies started out with the stage one. And then they sort of like, many of these companies, as soon as they realize that there is sort of like good amount of value to be generated, then they quickly sort of like migrated to stage two, where they then sort of like, started relying on their custom proprietary data sets. So, this would sort of like, involve, let's say, spinning up vector DBs internally so that, let's say, your internal data assets that you have, your structured as well as unstructured data that can be sort of like fed into these models rather easily. And then you can sort of like, create some compelling experiences for your end users. And then the next sort of like level that sort of like comes in is more to do with sort of like fine tuning or customizing your own sort of like models. Of course, now as you're progressing from one stage to the other, the one key aspect that sort of like comes in is that the nature of expertise that is needed in any company that sort of like, starts to sort of like go up. But then you also sort of like, in addition to that, start adding new components, right? So in stage two, we are already sort of like, starting to think about, let's say, what does data infrastructure looks like in the age of LLMs? And now, as soon as you think about, let's say, fine-tuning your models, then you also have to start thinking about what does your compute footprint looks like, because now you have to really sort of like worry about GPU availability and sort of like, how do you run your workloads that sort of like utilize these GPU chips as well as are able to sort of like fit well into your data ecosystem. Then now, very increasingly, what we are seeing is that many companies who sort of like started out with fine-tuning their models, of course, like the very first approach that they took was, let's say, spinning up a notebook or logging into, let's say, some sort of like GPU instance and fine-tuning that model once, deploying it elsewhere to see sort of like, what kind of product experiences can be built out. But then as soon as that sort of like becomes promising, then the never-ending race in many ways sort of like starts, because now you're basically sort of like wanting to iterate on these models, try out different fine-tuning strategies, try out different sort of like sources of data very rapidly and see sort of like what the impact of any of these approaches is on the final sort of like result that you have. And this sort of like, then starts to look more like your data engineering workloads, more like your traditional sort of like ML workloads. Of course, there are still sort of like massive differences in the shape of the problem, but conceptually sort of like, we sort of like start to get back into the same world that sort of like, most of us here in this call are very much familiar with. And then, of course, the most sort of like complex stack that, let's say, the cursors, the windsurfs of the world, all sort of like, um, well-known AI products are using today is not only just sort of like, let's say fine-tuning their models, but also investing very significantly in post-training these models and introducing sort of like, a lot more customization, offering these models in a variety of different modalities and really sort of like, innovating on each of these layers. And this world, sort of like, if you think about it, the main components there are: what does your data stack looks like? What does your compute stack looks like? How are you thinking about, let's say, authoring your workloads so that these workloads can actually sort of like run on this compute footprint and really sort of like, work well with your existing data assets? So what is the orchestration story there? As you're iterating, are you thinking about, let's say, versioning your code, your models, your approaches? Many people may call it like, experimentation management or eval management or prompt management, but there's sort of like, some significant need on that front. And how are you thinking about, let's say, deploying these models or using these models in any sort of like reasonable capacity? And then are there sort of like specific innovations that you're sort of like bringing to the table as you're, let's say, going out and sort of like, building these sort of like systems? And that's where we have focused for multiple years with Metaflow. So our sort of like key philosophy is that most companies have already sort of like made significant investments in each of these areas. So the goal here isn't to sort of like, come in and sort of like provide a brand new compute footprint or a brand new orchestration solution, but fit into existing capabilities that people may have within their organization. And I can just like, I know this is supposed to be a very quick talk. So over the next couple of minutes, I'll just like quickly show some code samples in terms of how we sort of like enable that with Metaflow and then how it sort of like works with Airflow. So Metaflow, at the end of the day, it's very simple looking Python SDK. So you can do a pip install Metaflow today and get started with that. And basically any sort of like functions that you have, you can annotate those with the step decorator, very similar to the task API that Airflow has. And you have this class that is sort of like building on top of this flow spec class. And this is all basically that you need to do. And now you can start running this flow locally on your laptop, and you'll get to sort of like benefit from a whole bunch of Metaflow functionality around reproducibility, snapshotting, and versioning without sort of like even worrying about anything to do with, let's say, your cloud footprint or your on-prem footprint. And of course, most workloads in the AI ML universe, they are very data intensive. So we have also sort of like, focused a lot of our efforts on providing tooling that is fast in terms of, let's say, bringing data sets from your data warehouses or your data lakes to your compute instances and being able to sort of like operate on those in a really efficient manner. As I mentioned before, anything that you run using Metaflow gets automatically snapshotted and versioned. And not only snapshotted, but it also sort of like, provides you everything in a rerunnable manner. So if you have, let's say, a colleague who ran some workload 6 months ago, you can actually replay their entire compute, their entire sort of like work, and then sort of like build on top of that. And the other thing that you would also notice is that because sort of like, we want to provide a very native Python experience, any sort of like instance variables that you have, they're automatically also sort of like made available to all the sort of like downstream steps as well. So then passing state becomes very easy and straightforward. But the interesting bits that sort of like, start to come in is, of course, you can run all of this sort of like locally, but many times as you're, let's say, dealing with these large models or large data sets, then you may not have enough resources on your laptops. So you can basically drop in specific decorators that will take your work, ship it into a cloud cluster, compute cluster in the cloud, and then run it and stream all the logs back to you so that we can basically give you an experience, let's say in this case, that you had maybe sort of like, 100 128 gig RAM chips installed on your laptop. And that sort of like, then brings the cloud much more closer to you. And of course, as I pointed out before, many other features. So I'll sort of like skip over that as well. But now the interesting thing for everyone is that, like, isn't this sort of like, something that Airflow also sort of like, does? Very much so. Where Metaflow basically shines is in the development part of the process, right? Like, how do you even come up with these workloads? And now, once you have this flow, which is basically sort of like a directed acyclic graph, then we provide one single command that allows you to export this flow into an Airflow DAG with all the functionality that Metaflow offers. So if you notice, we take care of moving massive data sets from one task to the other. So you don't have to worry about, let's say, fiddling with XComs or any sort of like, Airflow specific bits over there as it comes to, let's say, maximizing the performance of your workloads. But then most companies, they have sort of like, they are very heavily invested into the Airflow ecosystem. So you get to benefit from, let's say, all the alerting, all the tooling that you have sort of like built on top of that. There are like many other features as well. If this is interesting, I invite you all to sort of like, look at our docs. Those are available at docs.metaflow.org. We also have a sandbox that will basically spin up this entire stack for you in your browser. That's available on metaflow.org/sandbox. And if you're interested in chatting more, of course, we have a Slack community as well, where you are very much welcome. I might be out of time here. So I don't know if there are explicit questions. Brianna, how are we doing on that?
Oops, sorry, I'm muted. Thank you, Zevin, for going through that. So Brianna unfortunately had an emergency she had to step away for briefly, so I'm going to take over for her. Sorry about that, folks. Zevin, yeah, go ahead. If there are any questions, I don't see any in the chat. So let's go ahead and move forward. And then if anybody does have questions for everything that Zevin just covered, throw them in the chat. Zevin, I assume you can answer there if you'll stick on for a few more minutes. Thank you so much for going through that. We appreciate it. All right, folks, bear with me for just a minute while I pull up our slides. Let me see. All right, we should be seeing our PR number 45300. So that look good to everybody? Okay, great. So with that, I think Pugra is going to go over this next part, highlighting a really important contribution from last month.
Yeah. Thanks, Adam. Could I share my slides, please? Is it possible?
Yes, you can. Go ahead.
Really manage it. Okay, can everyone see my screen? Is it good?
We can.
Nice, thanks. Oh, welcome everyone, and yeah, thanks for joining. Today I will talk about like a short talk about a PR on IAP 81, which is related to basically making the CLI more secure. So what was the purpose of this PR is one of the core work of the IAP 81, which is the client and the communication mechanism between CLI and API. So it's basically leveraging the API security and the RBAC coming from there. And the changes basically on adding the client, authentication, the basic authentication via token, keyring integration, we will see in detail more in a short term. Environment creation, so that's also an important topic, which then you can have multiple environments like development, production, staging, instances where you can manage from like a single place without having much trouble. And for additional details on the technical side, like it's pretty much similar to what we did with our session. It's again a decorator. Basically, it's easily cascaded to any of the CLI. So let's continue. Okay, what happened in this PR is basically it evolved in a way that the Airflow CLI now as a separate package, we'll have a separate package called Airflow CTL. And thanks Coxil for allowing us to use the name, the father of the name, and we will have this as a separate distribution. We will still keep our core CLI features there. They will operate as the same as is now, and this will part of the where the communication will always through the API and will be more on closer to user side rather than administration side. So without ado, what was like the idea? Idea is the Airflow should use basic API endpoints, no direct communication with the database at all. And the token-based authentication basically decided across all Airflow APIs, which then integrated within the Airflow CTL as well. So it should be secure by design. Well, our API provide, and as well as on our Airflow CTL, we should provide that. And what could be that secure things is, so there were like a couple of questions in the while in development, like where to parse the token. It should be in a secure place. So we basically decided to use keyrings, where you can basically operating systems are providing also like third-party tooling, also providing some keyring libraries for to use. But this is like one of the secure way to parse passwords, tokens in the operating system. And also one of the other thing is when the token should expire. So you get the token, and if it live forever, then it will be like a backdoor if someone finds that token. So we basically create a new configuration under API out, which is like the CLI expiration time as a separate thing, because we think that the usual API token generation on the UI should be separate from the CTL, because their use case basically similar, but in a different way. So the number is in seconds, so sorry for the typo. And how the basically integration look like behind the scenes. So what we are going to do at the moment, and I will also share the future work, which will change a bit. The basically user will get their token at the moment. It's authenticating with the Airflow CLI, and that token is basically saved to keyrings, and all the communication through API will be used for that keyring, that token received from the keyring. So that will be posted, and when it's basically expire, it will basically push proper error messages to basically refresh your token. And in the future it can be automized. At the moment, how we are doing like the authentication is basically using Airflow CTL auth login. Current basically command arguments is like you can basically pass the API URL, token, and the environment, which I mentioned earlier, like the development, production, staging, whatever you call. And in the upcoming phase, we will basically provide this before the release, where you can basically pass the username and password to easily authenticate without providing any API tokens. So sometimes, passing the token from the parameter as a parameter could be seems like not secure, but if you use like environment variables or the environment variables we provide for these parameters. So you can use both for secure communication and saving, posting these things in a secure way, so that you can use Airflow CLI environment for, I think that's also a bit typo. That should be in different places. The token should be Airflow CLI token, and the M should be Airflow CLI environment in the Airflow out login command. And yeah, this will be like the entry point. So any command from this place should always need out login, but once until your token is expired for that specific environment, because each environment have its own specific token generated from the API. And further ado, I want to basically thank you, Ash, Kaxil, and Amok for Task SDK work and all the contributors, because behind the scene, we leveraged like the monoreport know-how. They are, of course, totally separate distributions, but behind the scene, both are communicating through the API, the Airflow API. There are, of course, like separation of public API and execution API. The Airflow CTL will talk with the public API, but behind the scene, the library, like the data model generation, all are like have the same approach. So yeah, that one I think like one of the important part for leveraging monorepo. It's a lot easier to basically use or leverage a lot of know-how. And yeah, that's it. Thanks for listening, and kudos to all contributors and basically guiding us through the IAP 81 to shape the future of the Airflow CTL. And yeah, any questions? I'm sorry. Yes.
Hi.
Prashant.
Yeah.
Go ahead, Prashant.
Yeah, I had some clarification questions. I was looking at the diagram, the sequence diagram that you showed. So, like the user, it looked like, as per the diagram, that the user already has the token. So the new utility, it's not used to generate tokens. It is like the user is supposed to already have the tokens, is it?
Yes, at the current like stage after this PR is merged, yes, but when we release the distribution, it will be automatic via you can basically pass the username and password and everything will be automatically generated. Like the token will be retrieved and will be saved to the keyring without like you have the token as a user.
Okay. Thanks. And is the main purpose of this utility to actually like save the tokens into keyring so that they could be reused?
For the keyring part, yes, but if you are asking on like in general Airflow CTL,
No, like the utility that you showed, like the main purpose is is my
this one,
understanding correct?
yes.
That the utility actually helps you to save the tokens into keyring so that they could be reused.
Yes, exactly. Yeah,
So
correct.
what is the scenario in which we will need to reuse the token? So are you saying like the token is still valid, but the session like for some reason we have lost the session, or is it like two different sessions you're talking about, like sharing the tokens?
Yeah, good question. Thanks. Thanks for the question. It's not using any session, so the client itself will be always generated when you call a command. So each command will load the JVT token and then use that token to communicate with the API. So let's say you run Airflow CTL connections get, then that token will be again retrieved from the keyring and then we'll make the call. And there is no like session in between or bursting anything. The only bursted part is the token in the keyring, and it always be reused when you call any command from the Airflow CTL.
Okay. So at the moment, like without the keyring, like how is it managed? Is it saved locally?
No, without keyring, it won't be work. So while we are basically releasing the distribution of Airflow CTL, we will propose like supported keyrings and installable keyrings that you can install. But the most crucial operating system keyrings will be also supported, like from the Windows, from the Mac OS, or like Linux. So those will be covered as well. So, but at the end, in short, yes, there should be a keyring in the running environment.
Sure. Yeah. Thank you.
Okay, great. Thank you so much, Prashant, for that question. And Bugra, thank you so much for your presentation. This was great. Really awesome contribution to Airflow, so thank you for that. If anybody else has any other questions, again, please throw them in the chat and we can get those answered for you, but we will go ahead and move along here. We do have a lot to cover today. So next up, we have Amog, who is going to cover another really important PR from last month in the Airflow project on handling custom XCom backends with the new Task SDK. So Amog, I will hand it over to you. Do you want to share?
Yeah, I would like to share my screen.
Perfect.
All right. Thank you, Kenton. So yeah, there you go. So right, I'll just start sharing. So yeah, hi everyone, Amog here. I'll be talking upon the recent work I've been doing with handling custom XCom backends on the Task SDK side. So even before we jump into why we are trying to handle it on the Task SDK side, one thing, there might be a general question that where is a scenario where this is helpful, right? So let's take a very simple workflow. So imagine I have a workflow with 2 tasks. The first one, it extracts Nginx log files from, let's say, S3, and Nginx log files are known to be, they're infamous for being huge in size. So this particular task just fetches those, filters it by debug logs, and let's say pushes it to XCom. And this is a scenario without the XCom backends. So in such a case, once this is pushed, I have another task running which picks up these XComs and it draws out a time, does some processing out of it. So to give you an idea, if I'm talking about GBs of log file data, I think a fair estimate for debug logs there would probably be, let's say, hundreds of MB for the sake of understanding things. So how does Airflow deal with this now? So just to stress on what the problem is, we can try and see the XCOM limit that Airflow enforces. So SQLite 2 GB, yeah, not bad, but due to multiple issues, it's not used in prod. Postgres is again 1 GB, pretty good again. But then MySQL is 64 KB. So you can imagine one of these tasks running and kind of going, sending the DB into a state where it's overloaded and things wouldn't work as expected. So how do you solve such a problem? So this is where enters the custom XCOM backend. So the custom XCOM backend is basically an interface that sits between Airflow and its metadata DB. And it can be any sort of a backend. So let's, for the sake of understanding, let's say it's object store. So if it's an object store, now you can define a threshold on it. And if the XCOM value that is right, that you're trying to push is bigger than that threshold, it's pushed into the object store directly, and its reference is stored into the database. And why the reference? So that other tasks and you yourself know where your XCOM is, right? So yeah, so the way to define this is generally, if you go to the documentation, you can see that there's a section for custom XCOM backends, and generally, oops, shouldn't have, yeah, generally clicking on overriding these two methods, the serialized value and deserialized value, and optionally the clear will give you a good enough backend that you desire. So the next slide is what are the challenges when I'm trying to get this to work with Airflow 3. So as we all know by now, Airflow 3 is it works in a client server model. So we have separated out the execution from the rest of the Airflow, which is the Task SDK and the execution API server, right? So that means that all DB access from tasks now happen via the API server. So if a task is trying to set an XCOM, it has to go through that, right? So can we send MBs and GBs of data over the network? I don't think that's a good idea. The other problem, the base XCOM class, if you have paid close attention to the code, it's a monolith, and it has provide session hooked in everywhere. So that means that it's not very easy to extend. If you because I'm talking about Airflow 3 where you cannot access DB from tasks. And if you're trying to write a custom backend by overriding some methods and it has a provided session, good luck, you can't do that. The next part, we need to worry about serialization, deserialization, and there's a client server model. Who does it? That's the other challenge. And the last one, ease of understanding. No, I looked at the code the very first time for base XCom and I could see stars all over. Just to give you an example, this is version 2.10 Airflow. So the base XCom class, you can see it starts with the table definition, goes into some ORM stuff, some more methods, and yeah, it's basically endless. Yeah, not too great, I would say. So yeah, this could benefit from some rework. So what did I do? I went ahead and took the initial basecom class and I split it into two parts right in the middle. The first one being XCom model. The second one is base XCom again, which is execution time, but it's not in the models anymore. The XCom model will solely only focus on the table and ORM related utilities like get, many, clear, set, etc., etc. And the new base XCom is used to interact with the DB, but through the task SDK paradigm, which is through the new API. So it has methods like the usual methods: set, get value, get one, serialize, deserialize, purge, delete, etc. But all of these have been rewritten to use the task SDK APIs now. And the serialization and deserialization has been handed over to the task SDK. So all interactions from the execution side to the Airflow side will happen in JSON-able objects now, not in JSON serialized strings, which I think made it slightly more complex. So yeah, the problems I'm talking about are somewhat real here. So what benefits do we derive from all of this, right? Yeah, the first benefit, serialization, deserialization is finally unified. So everything now uses the Airflow serialization module. We don't use JSON dumps, JSON loads, and keep interchanging between things like we did a few days ago. Then the core API and the execution API, they do not use the base XCom, the older one. Instead, we directly query the XCom model now. Earlier in these APIs, there was code which was doing stuff like base XCom.set, base XCom.getValue, and so on and so forth, not very readable. And Airflow models, again, this code talks to the XCom model directly. There's no base XCom involved here. And finally, the base XCom is in execution time, or truly where it belongs. And anyone who's willing to write a custom XCom backend can subclass from this one and go ahead and write their own backend. So these are the benefits it offers. So I would like to show a quick demo of what I've been up to. So yeah, here's my editor. So I wrote a very simple custom XCom backend here, which is, let me actually show this. Yeah, which is actually, it's a simple custom XCom backend, which is a file-based one, a JSON file-based. And what I'm trying to do through this is I have overridden the serialize and deserialize, like I mentioned earlier. So what I'm trying to do is when I'm storing data into the DB, or actually the file, when I'm trying to store it, I basically serialize the content and store it into the file I've defined with a write binary mode. And as part of serialize, we usually return the pattern or the path where we have stored the content. So I return that out as part of this. Similarly, in deserialize, I just get the path from where I've stored the data from the XCom model table. And once I have that, I basically go ahead and read from that same path, and that's that. So to show you how it works, I'm using Breeze here. So I've set these two environment variables. I'm overriding the core XCom backend config, and I have also added my code into file plugins for some reason. So I'm just adding that to the Python path, so it's recognizable. So once I do that, I have my Breeze running here. I will just go ahead and try to run a simple tag. Still running, yeah. Yes, so a simple tag that I'm trying to run, I can see that there are two tasks. The first one is kind of pushing a long message into the XCom. Second one fetches that out, and it's just adding a little more content to it and pushing it back. So I'm just going to run this one. Right, so the first one is through. Right, so yeah, the return value from the first one is the long message times 10. And it also pushes an XCOM, but if I go ahead and see what it's pushing, it's configured to use the custom backend. So it has pushed the path where it is stored. Similarly, for the pull task, it has pulled out from the last one, which is this long message times 10, added a little more content to it. I think scroll a bit. Yeah, added a modified 10 times to it, and again pushed it out. So if I, okay, if the database, if I try to query it from here, you can see that it contains the path here in the database. So where actually is the data, right? So that is in the worker. I'm going to shut the worker process. And I had mentioned this one to be this one, right? So just copy this out. We have a file, so I'm just going to do this, and yeah, there you see the new data being present, the modified one. So right, yeah, that was about my demo. I can take some questions in case you have anything.
Thanks
Hi,
so much,
Amok.
Amog. Prashant, thank you for raising your hand. I actually, just to keep us moving forward, because we do have one more speaker, if you don't mind throwing your question in the chat, and we can answer them there, that would be perfect. Thank you so much. Amog, that was a really great presentation, and thank you for the demo. We're really excited for this functionality coming out in Airflow 3. Okay, and so next up, we have our last presenter is Rahul Gade from LinkedIn, who's going to be presenting on how they optimize their large-scale deployments. Rahul, it's really great to have you on. Would you prefer to share slides yourself?
Yeah, I can share.
Okay, amazing.
Start sharing. Okay. You guys can see my screen?
Yes, we can.
Perfect. First of all, thanks for having me here. So I'm Rahul. I'm a senior staff at LinkedIn. Today we are going to talk about our deployment system, which is built on top of Airflow. And we'll talk about how we use Airflow to do deployments at LinkedIn. And this is a platform that is used by all like 10,000 plus engineers today to do deployments across ML models, across any stateless services, any stateful services. Everything in LinkedIn is getting deployed by this one single platform. So going next. So what was the vision for our continuous deployment platform? When we started in LinkedIn, we had multiple deployment platforms across LinkedIn, like one for stateful services, one for ML model, one for stateless services. So there were a lot of different deployment solutions, which caused a lot of toil for users when they switch from one platform to another. And the goal for this was to build a single deployment solution across LinkedIn that helps reduce user toil. Second but not the least, we wanted to build a platform which can be extended further for any partners who wanted to build solutions that can make deployments even further easy. Some things like validation tools, like if you want blue-green deployments, if you want canary deployments, all those tools can be easily plugged in into this LCD platform, along with also if you want to do chaos deployment, chaos monkey testing, all those things can be easily integrated. That was another goal for this platform. Last but not the least, we wanted to make the life of our users very simple when they want to configure these pipelines. And that's why we achieved no-code, low-code workflows, which also abstracted our users from understanding Airflow. They didn't have to understand the underlying platform that much in detail. Fourth but not the least, we also wanted to increase the overall continuous deployment adoption, also called as touchless deployments. When we started, the touchless coverage for LinkedIn was about 9%. And when we say touchless, it means as soon as your PR is merged, the code gets deployed across all the production fabrics without any human involved. With this platform, we are at about 60%. So that's an increase from 9 to 60% touchless adoption. We wanted to enforce best deployment practices without engineers in LinkedIn worrying about it. So we have stronger defaults in our platform, which engineers don't even have to worry about it. That means by default, they will be on to canary deployments. By default, they will be on the blue-green deployments. They will have adequate policies. That means, hey, there is a pause or a moratorium. You should not be deploying. Engineers don't have to configure all of this. We give to them for free. A high-level architecture that we have for this platform is like this. We have our custom UI, which is built on top of Backstage. We have our gateway service that acts as the entry point for any CLI and UI interaction. Below that, we have the Airflow. We have multiple clusters of Airflow to provide us HA. These Airflow run tasks as actions. We run Kubernetes. We have extended Kubernetes pod operator so that they can run as all these tasks can run as action short-lived jobs in a Kubernetes environment. So when we have a DAG, each task runs as a Kubernetes pod operator. That helps us to scale well and also helps our partners to write actions in any language that they want, right? So they don't have a limitation of understanding Python or anything. So they write actions in the language they like. They build Docker containers out of it, and we help them integrate with Airflow. And we also have two more services, which is like deployment transparency, which acts as a historical storage for all the events. So everything that is happening, the actions, they send messages back to deployment transparency so that we don't have to store all the historic events in Airflow. And that also abstracts us well from Airflow again. And all the historical details, we get it from deployment transparency. The overall architecture for Airflow is a well-distributed. We run it on Kubernetes. So we have our schedulers, we use Kubernetes executor, and we use Kubernetes pod operators to run our workers. And most of these then the workers start talking to the Kubernetes API server or the underlying downstream scheduler to do the deployments. I'll quickly show you what our product looks like today. So this is what engineers in LinkedIn are used to it. First up, I'll show you the YAML configuration that we have. There are three main things that engineers in LinkedIn really need to worry about. Like these are the three. Clusters is nothing but what are your production clusters that your code needs to be deployed. So you need to tell us where we want to deploy the code. What is your repo name or what is your deployable name? That's something you need to provide us. And what kind of deployment it is. Is it ML model? Is it Kubernetes? Lid is a homegrown scheduler. Those things, if you provide, that's good enough. If you want to custom build more things on top of it, that's where we ask users to provide more information, but this is like not necessary. Just providing this information helps us understand what is the pipeline intent. And taking this information, we convert this no code, low code into Airflow DAGs. So an equivalent of this would become this in Airflow. So let's look at the graph where once we click on it, we start. If you see over here, the user never said what is the deployment order, right? We don't even want users to worry about in what order to deploy. We have our custom logic where depending on traffic patterns, we understand what is the right cluster to deploy and we would choose it. So all those complexities are built in here. So where we do is we run a select canary, which based on the traffic patterns, understand which prod fabric to deploy. And then it will do a branching and decide, hey, is prod LOR1, LTX1, LVA1 right choice to deploy right now? Inside that, if you click in further, it becomes even more complicated where we will run canary. Canary is like, hey, rather than deploying on all the hosts in this cluster, we select few hosts first. Then we run analysis. We compare the new version with the old version. If it is safe, we decide to move forward. If it is safe, we decide to promote. That means now all the hosts will get that version. If it is unsafe, we will try to do a rollback, right? So if you see a simple pipeline intent, we converted into a lot more complicated structure behind the scenes, and the users never had to worry about it, right? So that's what we have built the abstractions to prevent users from understanding Airflow and also overloading them with all the deployment terminologies that we have, right? On the UI side, what we have is this is what a user sees, where they would come onto this page, which is built on Backstage. They would go here and they would try to search their pipeline. Based off that, we show them the pipeline, search, click on it. The users will land on this page, which is basically nothing but a history of all the runs that they had. Drilling down, they can get more details. Clicking into here, they get a rich history of, hey, what's going on with my pipeline? Again, all of this is built on top of Airflow, where if you see here, okay, currently it's in soak time. That's what the pipeline is going through. If pipelines fail for some reason, they can click into here. They get more details about why it failed, and we provide next steps. So the goal is to provide more actionable messages to users so that they know what to do when something goes wrong. We provide more information like who canceled the pipeline and everything, and so on. We also have a few more things built on top of it. This is like a grid view to understand what version is in which target right now. So here you can see currently this version 1911 is in progress and it is getting deployed across these fabrics, whereas prod LTX1 is still on this version and so on. So that gives you a bird view of the things happening in production. Yeah. And one last thing, a few things that we are doing on top of Airflow. We do extensively use like the pre-execute, post-execute. So what we have today is we customize the Kubernetes pod operator to have pre-execute and post-execute steps. These pre-execute and post-execute steps are the one where we run a lot of policy checking, like, hey, is it safe to run the action right now? And that is where a lot of data passing happens between Airflow and deployment transparency, the service that I talked about earlier. So that we have the information stored and we can still access that in future, later on in time. Yeah. So this is something that we have built on top of Airflow, and it has been going well. We today have onboarded about 700 services all at LinkedIn. In next 3 months, the goal is to reach to almost everybody in LinkedIn. That is like 2,000 odd services. And yeah, that's what we have been building in LinkedIn.
Awesome. Thank you so much, Rahul. I think that I have not seen any questions in the chat, but again, if anybody does have any questions for Rahul, please go ahead and throw those in while we have a few more minutes. And then I'm just going to go through a couple of things to close us out. Again, unfortunately, since Brianna had to leave, I don't have her community spotlight, but I did want to take a moment to just call out all of the amazing work that has been going into Airflow 3.0. We saw it in the dev list last night. The first release candidate is out for voting. So Airflow 3 should be coming out within the next couple of weeks. This represents a massive amount of work from the whole community, including, I think, a lot of folks who are on this call. So just to spotlight all of them, we are very, very excited for the 3.0 at Astronomer. I think everybody here should be as well. And again, that's something to look forward to within the next couple of weeks. Again, we will all be watching out for how the voting process goes. Okay. Lastly, I want to call out the Airflow Summit this year. Early bird tickets are available now. They're 35% discounted, so now is a great time to grab those if you know that you want to come. We hope you will. Airflow Summit is a great chance to meet a lot of folks who, like you have seen on this call, who are using Airflow in great ways at their companies who will be speaking. There will be lots of talks related to Airflow 3. It is going to be in Seattle, so I'll make a very personal plug for Seattle is wonderful. This is where I live. Early October, when Airflow Summit is this year, the first week in October is typically beautiful weather. It's a great time to visit. You can reach out to me on Airflow Slack if you want recommendations for other things to do during your visit. So again, now is a great time to get tickets, especially if you know you are going to have to travel or travel internationally. Great time to get that process rolling. So, okay. And then just as a closing remark, we really appreciate everybody joining us for the monthly town hall this time. Just in case you are not already aware of these things, in terms of keeping up with everything going on in the community, these happen the first week of every month. So next month will be a particularly excited one because we will have lots of Airflow 3 stuff to cover. But in the meantime, we really hope that you join the Airflow Slack. That's a great way to keep track of everything that's going on in the project, answer questions for folks, get your own questions answered. If you are in an area where there are local meetups, which is many of them, you can join the local meetup group, which is great. Subscribe to the newsletter and finally join the dev list, which I just mentioned is where currently there's lots going on, especially around Airflow 3.0 release candidate voting. So that can help you stay up with the kind of development side of the project. Okay. So again, thanks to those for joining. I do see one question about the Airflow Champions program that I am just going to forward to Bree, so we will follow up with you on that when she is back in the office. Okay, so thanks again to everybody for joining us, and we hope to see you next time. Okay, bye folks.